Today we'll continue with our topic of electromagnetic waves, and I'll start off with the communications with satellites. Uh, Communication with artificial satellites use microwaves. So artificial satellites, we are talking about that they are actually natural satellites. For example, the moon is a natural satellite of the Earth. So artificial satellite is any satellite which we launch into the space so that it can orbit the Earth. Those are artificial satellites. So when we are communicating with artificial satellites, we use microwaves. We produce microwaves. These microwaves, they go to that satellite, and that satellite responds by producing its own microwaves, which are beamed down to Earth. Some satellite phones use low orbit artificial satellites. They're actually phones, satellite phones, whereby you are having a phone and you can make some calls and you can even access the internet directly using the low orbit satellite, which means that even if you go to places where there is no network, you can still be able to communicate with people because you are using the low orbit satellite. So there are phones which work on that one, and then there are some satellite phones and direct broadcast satellite televisions which use the geostationary satellites. So we shall talk about what is geostationary satellites as we shall do next. So there are two types of orbits. There's the geostationary orbit, and then there is the polar orbit. Polar orbit is usually what we call the low orbit satellite. So as you can see here, they almost go at 90 degrees to each other. The geostationary satellite in the geostationary orbit and the polar orbit, like that. They almost go at 90 degrees to each other. So what is it about low orbits or polar orbits? Polar or low orbit satellites orbit around the Earth's north and south poles. So these ones, their orbit will pass through the north and the south pole of the Earth. These orbits are much lower than the geostationary satellites. They are about 200 kilometers above sea level. So the 200 kilometers, of course, is a very big distance, but in terms of space, in terms of orbit, that's a very low distance. They are used for monitoring the weather, military applications, and taking images of the Earth's surface. There is a much shorter time delay for signals compared to geostationary satellites. What do I mean there? By time delay, I mean that when a signal is transmitted from the surface of the Earth, it goes to the satellite and then it is beamed down back to Earth, to another place on Earth. The time it takes for that to happen, we call that time delay. Because since these satellites are nearer to the surface of the Earth, the time taken to go up and to come back down on Earth of a microwave wave, it's actually shorter. So that's what we call that the time delay is shorter. The signals and the image are much clearer due to the lower orbit. So because these satellites are nearer to the surface of the Earth, they take better pictures. They take more high resolution pictures. However, there is limited use in any one orbit because more than one satellite is required for continuous operation. So when you're using polar orbits or low orbits, we cannot just use one orbit, one satellite. We have to use many of them we have to launch many of them into the space, because having just a few, they will not operate and they will not work well because they are too near to the Earth. It means that they don't have access to other areas of the Earth.